Hi, I'm Andrew Connell, and I'm an MVP for Office Servers and Services and Office Development. In this module, we're going to talk about building Microsoft Graph applications and looking at a .NET console application using the Microsoft Graph. This module includes a lab for building a .NET console application using the Microsoft Graph, but in this screencast, we're just going to look at the pre-built sample that you would have if you already had built the application doing the lab. So in this first section of this module, we're going to talk about building a .NET console application using the Microsoft Graph. We're going to look at the application registration process. We'll talk about the NuGet packages that are involved in building the application for a .NET console application. We're going to look at the application experience, and then we're going to do a little demo of the overview of the entire sample. Let's first talk about the application registration. The application that you're going to build has two components to it. There's the actual code of the application, and then there's also a registration component that you're going to have to do with Azure Active Directory or Azure AD. Now, to create the application in Azure AD, there's a couple different ways you can do it. And the most popular ways doing it through the browser is either using the application registration portal or by using the Azure Active Directory portal from the Azure portal. We're going to use the application registration portal that you see here on this slide. It simplifies things a little bit and it's a little bit more of a wizard kind of experience. What you're going to do is go to the application registration portal and you're going to create a new application and you're going to give it a name. In this case here, you see it's console demo. This is going to generate a new GUID or an application ID that you're going to use to identify your application. You're then going to specify if the application, what kind of a type of an app it really is. Is it a web application or is it a native application? Web applications are fairly explanatory. A native application, though, is one that would be either a console application or a mobile application. In this case here, we're building a console app. So we're going to create a native application. You see there that it's got a custom redirect URI. Well, web applications, it's pretty easy to understand. You're going to send it back to a certain URL. Once the user logs in, they're going to be sent back from Azure AD once they've authenticated back to your web application. But in this case, we're building a console app. So that doesn't work. In this case here, we just have a special endpoint that we're going to use to pass back to our application. And that's a special endpoint that's dictated by the Microsoft Graph or the Microsoft Authentication Library. The next step is establishing the permissions that your application needs. Now in Azure AD, we have two different types of permissions. We have delegated permissions and application permissions. Application permissions are very powerful, and what they allow an application to do is to authenticate to Azure Active Directory all on its own automatically with just a equivalent of an application username and password, or an application password and application ID. This is going to allow the application to run in a headless mode. Very common, like a scheduled service or a daemon that's going to be interacting with some data, but not having any user involvement when it runs. These applications are going to require a more privileged user to grant them access to your directory or to whatever the Microsoft Graph has access to. The other type of application is called delegated type permissions. And these delegated permissions, what they allow you to do is for a user who has specific permissions to grant an application to do things on that user's behalf. And in effect, the user is delegating those permissions to the application. In this case here, we're using the user.read and the user.readBasic.all permission scopes. The user that's granting the application access to do those things must have those same permissions to grant the application access to work on its behalf. Now let's talk about some of the NuGet packages that you're going to use inside of a .NET console application. The first two that you're going to need are the Microsoft.graph and the Microsoft.graph.core NuGet packages. The Microsoft.graph is going to use the NuGet Microsoft.graph.core package as well as the Newtonsoft.json package. Those will all be included in your project. The reason why the Newtonsoft.json project package is required by the Microsoft Graph is because it's used as an open source library that's very common and very popular for serializing and deserializing and working with JSON data. The Microsoft Graph responds and requests data going to and from it to be in the JSON format. And this is going to make things a lot easier for people to work with JSON data using the Newtonsoft JSON NuGet package. In our case, we're not going to really need to worry too much about that because the Microsoft.graph NuGet package is the SDK, and it's going to interact with all the data going back and forth to the Microsoft Graph for us. We're just going to have to work with a strongly typed and fluent SDK. In addition, the Microsoft Authentication Library, or MSAL, is what we're going to use to do all the authentication work to and from the application and with the Microsoft Graph and Azure AD. This is going to simplify the authentication flow quite a bit, and you'll see this in just a few minutes. Now, at the time of the recording of this module, the Microsoft.identity.client NuGet package, which is the implementation of the MSAL library, is in pre-release mode. So if you're adding the NuGet package using the Visual Studio NuGet package manager, the GUI tool, you need to make sure that you have the little checkbox that says to include pre-release packages in your search results. Make sure that's checked when you go to search for this package. Otherwise, it won't show up. If you're doing it through the Package Manager console in Visual Studio, make sure that you include the -pre attribute on the install package commandlet. Otherwise, it won't be included. This way, you'll get the pre-release version of this library that we're going to use in the library. And don't be afraid of it being a pre-release. It's still in very good shape and it totally works. However, you do want to pay attention that when this library is released to production and the pre-release flag kind of goes away and it's updated for general availability, you're going to want to make sure that you re-add this project or update it without the pre-release version. Now let's look at what the application experience is going to look like when you run the application. The first thing the user is going to do is be prompted to sign in. Now, when they go to sign in, they're going to be signing in using the Azure Active Directory authentication endpoint. And when they do this, they have one of two options to authenticate. They can either use their work and school account, which is also referred to as their Office 365 or Azure AD account, or they can use their personal account, which is also referred to as their Microsoft account or MSA, or you can refer to it as a Live ID, which is what we used to call it a long time ago. Either way, they're going to be prompted to authenticate. They're going to have to use proper username and password that they want to authenticate with. If they're authenticating with a work and school account, they're going to have access to data inside of Office 365 or into Azure AD, whatever the Microsoft Graph is exposing and supports. If they log in with a Microsoft account or an MSA in their personal account, then they're only going to have access to consumer-based resources like OneDrive Consumer or Outlook.com-based email stuff. So they're going to have to first log in. Now, once they log in, the very first time they go to use this application, they're going to be prompted for consent. And what this is doing is that Azure AD is looking at it and saying, well, this user has never logged in with this application, so this user has never granted this application access to their data. So what it does is the Azure AD is then going to prompt them a consent dialog, which is what you see in the middle of the slide. It's going to show the name of the application, and it's going to show the implication of the actual application, so the publisher of the website. And what it's going to do is it's going to show them a list of all the permissions that the application is requesting, and it's also showing them who they're signed in as. So the user must accept this for the application to work. If they don't accept it and they just hit cancel, then the application will not be granted these delegated permissions for the user. Once that happens and the consent dialog goes away, then the console application will then fetch the data from the Microsoft Graph that's been specified and then show that data on the screen. Now let's look at a little overview of how this application works under the covers. The authentication story, when you look at OAuth-based authentication or OAuth 2-based authentication, working with Azure AD, it can be a little confusing. And so let's take a second to just understand what's going on. It looks pretty complex, but don't worry. Actually, it's going to be implemented. We're using these different NuGet packages and the Microsoft Authentication Library, which will make life a little bit easier. Let's first look at the high-level piece of authentication and then showing the data. What we're first going to do is go to sign in. And the way that that's going to happen is that from our application, we're going to be redirected to the Azure AD OAuth 2 endpoint, and that's at login.microsoftonline.com. So I'm first going to go to login. And once I log in, the application is going to get an access token, an OAuth 2 access token from Azure AD back to the application. And what that is going to do is that access token is effectively going to be able to tell the Microsoft Graph that, hey, I've got a key to be able to come in and get data, and this is who gave it to me. And then Microsoft Graph says, oh, I can see that that key is from Azure AD. I trust Azure AD, and I can see that that key is for a specific application to talk to a specific endpoint. So I know that that's going to be valid. Azure AD would not have given me that key or that access token if I had not already gone through the consent framework, consented the application access to my data, and logged in successfully. So then the application is going to reach out to the Microsoft Graph and request my profile information, which the Microsoft Graph will return. Then the application will then ask for all basic information about all the users inside of my directory, and then show all that data back using just the basic profile information, handing that back over to my application, which will display it in the console. Now again, this whole process of authentication can be a little confusing. So let's talk about the authorization code grant in this V2 endpoint. This can get to be, like I said, a little complicated and confusing. Most of this stuff though is going to be handled for you, so you're not going to have to worry about this too much. Once the access token has been acquired, your application is going to continue to call the Microsoft Graph API without going through all the steps to obtain an access token. Instead, it's just going to hold onto that token locally and keep using that. But at some point in the future, the access token is going to expire. So you're going to need to take that access token and use something called a refresh token that you got when you got the original access token. And you're going to use the refresh token to call back to Azure AD and tell it, hey, I need a new access token. That's going to allow you to bypass the user from having to log in again. So let's first look at how this whole process works. The neat thing about this is that in order to understand why we need the Microsoft Authentication Library, or why MSAL is important to us, you should really understand what's going on under the covers. And that's what this slide is really doing here. Your code is going to follow a very simple pattern to acquire a token silently. And when that fails, it's going to try to acquire the token interactively. So when I first go to log in, if I don't have a token, that's going to fail to go call the Microsoft Graph. And that's when I'm going to be redirected over to go log in. Your code does not need to manage the login pop-up screen. That's all going to happen for us. The interaction of doing the login screen, for managing and obtaining the consent, and it also doesn't need to manage the token lifetimes. It's all going to be handled for us by the Microsoft Authentication Library. What's going to happen there at the very top is you see that we're first going to go log into the application, and that's that first step where it's asking to first go not only log in, but it's also asking it to that authorize endpoint. It's saying, once you've signed in, I then need to consent the application to do some work for me. I want it to go use these specific permissions. You can see there in the slide where it is requesting specific permissions, and those are also called scopes. Once I've successfully signed in and I've granted it that access, then I'm going to get what's called an authorization code back. And that's where this OAuth 2 authentication flow gets the authorization code name from. That authorization code, you can think of that as just like a key, or not even really a key. It's more or less just like a permission for the application to go get a token from someone else. So you see there in that next line is that what it's doing is it's going to then request the token from the token endpoint using that authorization code. So it says, here's a code that I got from Azure AD. This code is only good for a very short period of time. And what the token endpoint will do is it'll look at the authorization code, and it recognizes that that code was generated by Azure AD. So it trusts itself because we're still in Azure AD, we're at the token endpoint. It's going to then generate an access token and a refresh token and hand those back to the application. The application can then use the access token to call the Microsoft Graph, as you see there. Now, hypothetically, let's just say that the access token expired. Well, when that expires, then we can use the refresh token to call back to the token endpoint to get a new set of access tokens and refresh tokens that we can then go back and call the Microsoft Graph here. It's important to cache the refresh token, though, to request a new access token. The good thing, though, is that this is what the Microsoft Authentication Library is going to do for you. There's no action for you to do as a developer to manage the refresh token. You can create a custom cache for persistence, but the Microsoft Authentication Library is going to manage the actual token lifetime. However, it is important, as I've shown here, to understand what this library is doing on your behalf. So now let's switch over to the demo and let's take a look at our .NET console application. In this first demo, we have a console application that's going to show off working with the graph. But first, we're going to handle the creation of an Azure application using the app registration portal. I'll start by going to the app registration portal, and then I'm going to click Add an App. I'm going to give it a name. I'll just use the default email, as that's the account that I'm logged in with, and then I'm going to go ahead and click Create. Once the application has been created, it'll display the name and the application ID, which is dynamically generated. Now, the next thing we need to do is we need to specify a platform. And this is going to be essentially the kind of an application that we're creating. I'm going to select a native application because this is going to be a console application. We would pick web app if we're picking something that's more interactive for the end user, but native app is going to be used for console apps or mobile apps. Now, I'm not going to need to set the redirect URL here, or URI, which would take me back to the login page or the authorization page in my application. And that's because we have some built-in redirect URIs. As you see down there at the bottom, we have a default one that starts with URN, IETF, and so forth. We can use that one. We don't need to leverage a custom one within our native application. If it was a web app, then we would be setting a URI, a native URI at the top. Now let's scroll down to the permissions section. As you see here, we already have user.read, which is the default permission. But if I click Add, I can see where I can choose a bunch of different permissions. If I scroll to the bottom, you'll see one for user.readbasic.all. And there's a couple different options we have here. I can either choose to, if I select this, that we do want to use this permission, we can use the delegated permission, which is the first column where it says user can consent. And this is where, if I was using the common consent framework and allowing the user to grant consent to this application to act on my behalf, that's where it would be using that first column. The other option is to use an admin consent. And what that is that I would do a special kind of a consent when the user goes to log in. I would send a special parameter over to the Azure login page, or the consent page. And what that would require is me being the person logged in would have to be a global tenant administrator. And then that user, once they've logged in, they can then grant this permission to all users within the organization or within their Azure AD tenant. So this is an all or nothing based thing to do admin consent. We don't actually need to check this permission or add it because we're using the V2 endpoint, the OAuth V2 endpoint, which allows us to do something called dynamic consent, which allows us to specify the permissions on the actual URL when we make the request, so that when the user needs permissions for something, we can request it on the fly instead of having to define it ahead of time. So all that's left to do here is just go ahead and click Save. Once our application's been saved, we then need to get a copy of the application ID, as we're going to need that within our application. So once I have the ID, I'm then going to jump over to this graph console application that I built ahead of time. And I'm going to open up the app.config file. And in there's an app setting with a key called client ID. That's the application ID. So I'm going to take that ID and I'm going to paste that into this setting here. And that's going to effectively configure my application to use this application, this Azure AD app that we just created using the app registration portal. So let's take a look and see what this console app is going to do. Let's open up the program.cs file, and I'm going to scroll down to the function run async starting on line 17. And you can see here what this one's going to do is it's going to call a function called getMeAsync, and then once it gets the information about me, it's then going to write that information out on the console. So it'll write my display name, and it's also going to write out my email address as well on the screen. Another thing that this console app is going to do is it's going to call a function called getUsersAsync, and what that's going to do is effectively the same thing you just saw a second ago, except that it's going to get information about all the users instead of just one user inside of my current tenant that I'm in. So here, once I get all my users, I'm then going to enumerate through each one of them, and I'm going to write them out onto the screen. Another capability that the graph provides is the ability to get people near me or people that are relevant to the current user. And these are people that the graph has figured out based on my activity of things like emailing these people or being in meetings or collaborating with them on documents, where it's figured out that these people I'm closely related to them. So this is something that the graph can return. So I'm going to call a function called get people near me, and it's going to give me a list of all the people, and then I'm going to enumerate through all those people and write those out, people out as well, the same way you saw previously. So let's look at each one of these different functions that I just referenced. So the first one is get me async, and that's the one that's going to get the current user's information. So you see here what this will first do is use the Authentication Helper object from the MSAL authentication library. And it's going to get an authenticated client. And that's going to be a graph client. That's going to be the actual client that I can take advantage of. That's going to give me from the NuGet package that we have available to us for working with the graph. As you see there, this is an asynchronous function. So I'm just going to say graph client.me. I'm going to go request my information and then say go get it asynchronously. And once I get that, that's the thing I'm going to return back to the calling function. Well, let's dig into this a little bit more. Let's see how we're actually getting that client. So if I go to the definition for the Authentication Helper getting the client for me, or get the authenticated client, what you'll see here inside this file is that I have a couple things. First, I'm getting the ID of the application, which you saw us paste that in from the app.config. But I also have a list of scopes. These scopes, these are also seen as permissions. I mean, so you kind of, the name scope and the name permission, they're almost, you can think of them almost interchangeably in the context of Azure Active Directory. A scope is a permission. Here you can see down in the code here for get authenticated helper, what I'm doing first is I'm checking to see if I already have an instance of the graph, because that's going to be something that we'll be able to cache and be able to reuse over and over. What I'm first going to do is try and create an instance of the graph. So I'm going to say create a new graph service client. I'm going to pass in the endpoint. That's the V1 endpoint is the production endpoint. And then I'm going to pass in a delegated authentication provider. And what this is this is going to do the work of trying to go authenticate for me. So it's going to say get token for the user async. And what that does is that's going to go try and obtain a OAuth token for me. Once I then obtain this token by calling that get token for user async, which is another method that we have inside this library, I'm going to get that token, which is effectively my key to be able to go obtain data and authenticate with the Graph SDK. Once I get that token, I'm then going to set the token in the request header. So the header value is authorization, and then the value of that header is bear space, and then the actual token that we're using. And that's going to authenticate me with the Graph client. So let's dig a little bit more and let's see how we actually get this token. So if I jump to the method of get token for user async, as you can see what this is doing is it's calling the identity client app. That's part of the MSAL SDK. And it's calling a method called acquire token silent async. So you can see there's another one just below it, the acquire token async. Let me explain the difference between these. So the first one, as you can see, they're both passing in the scopes. And so the scopes are the list of permissions that we need. So what I'm doing here on the first one is that I'm passing in the permissions and I'm passing in the current user that is logged in or that we know about. What this function is going to do under the covers is that it's going to check its internal cache. It's going to see, do I already have a access token for the target thing that I'm going after, for the graph, that has been granted, that is going to work for the permissions that I've specified here for the current user. And if I do, then it's going to fetch that token and it's going to return that back to the caller. If I don't, or if that token is expired, let's do the two different cases separately. If that token is expired or is about to expire, then it's going to also grab the refresh token that it has in the cache from when it originally got the token, and it's going to try and go get a new access token and a new refresh token from Azure AD. And if that's successful, then it will update the cache and it'll return back the new token for us. So it tries to go get a token for us silently behind the scenes. If it's not able to, then it'll throw an exception and it'll say the MSAL UI required exception. And what that basically means is that, hey, I can't go get a token without the user involvement. So a case for this would be the user has not granted consent or gone through the consent framework to give the application access to use have delegated access to to those different permissions. So here I fall into the next set down on line 69 that is acquire token async. And what that does then is that's going to go through a whole process of prompting the end user to go log in and to go through the consent framework to get the token. And then once it gets the token and the refresh token, the application will then, or the MSAL authentication library will then take that information and will save it to its local in-memory cache. So let's see this thing in action. I'm going to go ahead and hit F5 and get the application to start running. And you'll see we'll hit the first breakpoint to try and acquire the access token silently using that silent async method. Here you can see the two scopes that we're using, user.read and user_read_basic.all. And if we scroll over a little bit, we take a look at the users that we're passing in, and you'll notice that we have 0 users. So what that means is that this is going to fail. We don't have, the user's not logged in, we don't know about this user, so there's no way that we could actually show them any of this information. And so because we're passing in no users, we know that this is going to fail, or we know that it's going to throw an exception, so we will then fire off that exception. You see here that we're then going to go through the acquire token async, which is going to trigger an interactive login. And if we step through this, you can see that we get a little dialog that's going to pop up and request us to log in to our account. So I'm going to go ahead and log in using my test account here into my test tenant. And once I've pasted in the password, you see here I'm now getting the consent framework. It's now asking me that it needs certain permissions. So it needs my basic profile, access to my data, signing in as me, and also that other permission that we could have added that you saw when we registered our application about adding or reading all users' basic information. We did not check that, but we're using the V2 endpoint, which allows us to pass that permission across dynamically in the scope when we actually do the request. So here I'm just, if I click accept, that will accept the common consent framework, or go through the common consent framework and accept that permission request so that we can get our access token. And here you see after I've clicked accept, if I go back to my application, it's now going to hand me back an access token, which you can see in the autos panel at the bottom left, where you can see the value of our access token. And then that will go back to our caller, which will then use that access token to stick that in the header to create an instance of the Graph client that we can use. And so here, once I now have my Graph client, you can see that I've now take that Graph client and I can then make the call to go get information about the current user. You can see I have the user name coming back, which is the MOD administrator. You can see my email address is coming back. So all the information is coming back from Graph just as we would expect. And if we go over to the console, which is running over on the side, and we open that up, here you can see that in the console, we are also getting the result coming back as well. So we can see the stuff being written out just as we would expect. So let's take a look at the other example that we had, which is to get all the users. So here, I'm going to first call that function that's going to go say get all of my users. That in turn is going to go try to get our Graph client or authenticate. And you can see that because we already have an instance of the Graph client in this application, it is not null. So we'll just return that back to the caller. Now, what you'll notice here, though, is in the call is that whenever we make the call to get some information from the Graph, you'll see that it's always going to try and do that same delegate call to re-authenticate and get some information back from the or get the token back. So it's always going to check to see if we can still use that token when it builds up another request. And that way, it's also checking to see if the token is still valid or if it's expired and if it needs to refresh the token for us. And so as you see, just like we did before, it's going to then say, let's go get a token. This time on the silently method, it is going to get a token because we have already logged in and that user's information is already in the cache, or the user and the token for those scopes is already in the cache. And so it's going to retrieve that. It's not going to throw the exception, and it will be able to return back that access token. And so here now you can see that when it runs this time, it's going to go fetch the information for all the users in the tenant. And if I switch over to my console, here you can see a list of all of our users, again, showing up in our tenant. Now let's look at the last demo, which is getting all the users near me. And this one's a little bit different from how the other ones work. What this one does first is, like the other ones, is it's first going to get a reference to the authenticated client, and because we know we already have that client, it's going to go get the same one that we were using before. And then it's going to go get a token for the current user. Again, it's getting the token for the current user asynchronously. Now, this one's going to show a different way to go through and get that token. So instead of using that delegate method that I showed you earlier, this one's going to go get the token directly. So you can see I'm making a direct call here for get the token for user async. And then what I'm doing is I'm using the system.net namespace to set the header myself manually on this value or on the request that we're going to end up making. All this is showing is just another way of doing it. It's not showing you the way that you have to do it for this one. I'm just showing you another option so that you have in this console app, you can see how we have the delegate method and then we also have a direct method. You can see here that I'm now going and creating the request directly. So you can see I've got the HTTP method get, and then I'm also creating the graph client base URL and appending on the me/people, which is the endpoint for getting people near me. The next step is then to set the authorization header, as I mentioned a second ago, and we're doing that by fetching the token directly. That's already in cache, so it's not going to make a separate call to go get that for us, thankfully. And then I'm setting asynchronously, I'm setting the request and then making the request to get the response back, looking at the response and reading the entire string that comes back asynchronously. So in this, if I switch back over once this thing is run, let me say it again. And so after this one has finished executing, what this is then going to do is it's going, if I jump over to the console app, you can see that instead of listing out all the users, I'm only listing out some users. And as you can see, I have things like a conference room that's listed, some of them are people, some of them are groups, and it really just depends on what I've been interacting with, what the graph comes back and says, these are the things that are most relevant to you. And so this demo has shown how to call the graph and authenticate a couple different ways and use a couple of the different endpoints that we have available to us in the graph as a console native application. In this next section, we're going to look at building Microsoft Graph applications, but using a JavaScript application that's going to call the Microsoft Graph. So what are we going to cover in this section? We're going to first look at the application registration process. We're going to look at obtaining all the packages that we're going to need for our application. We'll look at the application experience, and then a quick little overview of the sample as a demo at the end. The first process is going to be to create the actual application registration in Azure Active Directory that our code is going to leverage. So this process, like the previous process before, is going to involve either using the Azure portal or the application registration portal. We're going to use the application registration portal. Here you're going to create a new application, and you're going to give it a name and get the ID back. And then you're going to then add the platform that it's going to be taking advantage of. In the last example, we use a native application. In this one, we're going to use a web application. This web application is going to need a couple different things here. First, it's going to need the redirect URL. And what this is that when I go to run the application and then I say I want to log in so that I can actually call the Microsoft Graph, it's going to send me to Azure Active Directory to go authenticate. Well, once the authentication process has completed and I've successfully authenticated, I'm then going to need to be sent back to the application, my web app, the custom thing that we're building. In this case here, it's going to be running off my local machine. So I'm going to put the redirect URL to be HTTP localhost 8080. But in production, that may need to go to https://contoso.com/signin or auth or something like that. You're also going to need to select that allow implicit flow checkbox. And we'll talk a little bit more about what that is in just a moment. Now, the next thing we're going to need to do is to install the Microsoft Authentication Library package. Now, because this is a JavaScript-based application, this JavaScript app is going to be using the package manager called NPM, or the Node Package Manager. And what this is going to do is we're going to use this to install the Microsoft Authentication Library. You can go see the github.com/azure-AD/microsoft-authentication-library-4-JS when you want to look for additional information on this library. Now, note that the Microsoft Authentication Library, or the MSAL.js, is built for ECMAScript 5. And so therefore, it's going to allow us to enable support for IE 11. If you want to target IE Internet Explorer, you're going to need to add a reference to the promises polyfill. And you might want to read more about that in the frequently asked questions for the Microsoft Authentication Library URL that I provided before. Effectively, there's a couple polyfills that are available to you for a library called Bluebird and the MSAL that are available for via CDN. And all that information is available to you as shown on the project page for the Microsoft Authentication Library for JavaScript, which is included in the notes on this slide. Now let's talk about the application experience. What is this going to look like? Well, first, when you go to run the application, the user is going to be prompted to sign in. So they're going to navigate to localhost 8080 and click the connect button. And that's going to prompt them to go sign in. The user is prompted to grant consent to the application if the app administrator has not granted consent for the entire tenant. So in this case here, I haven't. So what I'm going to do is then have to go specify the different, have the permissions that are already specified when I created the application, just like you saw in the previous example with the console app. And I have to go through the consent framework and grant the application access to go talk to that data. Once that happens, and I do the authentication dance, I'll be sent back to my application, which it'll get the data that it needs in the access token, and then it will use the Microsoft Graph to get data and return it and show it in the client. Once you then click that button, an email is going to be sent using the email that you've specified there. It'll be being sent from your account as it has access to send an email as you. As you see in that middle picture there on the slide, I will be granting it permission to send the email as me. So let's take a little overview of the sample that you can go ahead and build inside of the lab that's associated with this module. Now, what's not shown in this diagram is that it's recommended for JavaScript apps using either the Microsoft Authentication Library or the ADAL Authentication Library to first call its own endpoint, passing in the ID token to validate that the token is intended for the app for replaying the token. And what that's going to do is it's going to make sure that there's not a man-in-the-middle attack going on. It's a bit beyond the scope here to validate the token that comes back because we want to try and show an example here that is all client-side based. Validating a token that we get back from Azure AD is something that you're really only going to be able to do server-side. You can't do that client-side, but it's really beyond the scope here. So there are examples on the Azure AD GitHub organization showing examples of this. So when we first go through and run the application, we're going to go first say connect, and that's going to take us to the login.microsoftonline.com site to go authenticate and obtain an access token. Then once the application gets the access token, it'll call the graph and pass that access token across and requesting my profile information. My profile information will then come back, and as you see there in the screen on the little computer in the picture is that it shows my name. So in this case here, my name is Ben Walters, is the little sample that we're using. And when I click on that, it's then going to return back and show me my information there. It shows that it's Ben Walters. Then I can send an email from this account, or from the Ben Walters account. So there I can plug an email address in and then just click send email. And what that will do is that will send an email using the Microsoft Graph API to send an email from the currently logged in user to the target email that I specify there. So let's talk a little bit about the authentication flow for a JavaScript client-side based application. This slide is going to show how this protocol works and what the Microsoft Authentication Library is going to do for you. Now, the JavaScript applications using the V2 endpoint work very similar to other types of applications, but we use the OAuth flow called the implicit flow. So how does this work? Well, the implicit flow differs from the one that we saw in the last section called the Authorization Code flow, in the sense that there's no token or no code that is returned back to the application to go fetch a access token. Instead, I'm just going to go log in, and then the application is going to get the access token back from Azure AD. It's not that this is an insecure way to do it, but I wouldn't say it's anywhere near as secure, and it's one that you have to opt into when you want an application to use the implicit flow, because it is maybe you can look at it as a little less secure, but it's just one that you just need to keep in mind. Now, the call to the authorize endpoint, that common/oauth/v2.0/authorize, that's going to pop up the login screen and request the permissions consent. And like I showed you, or I mentioned, unlike in the previous section using the code grant, there's not a separate call to go obtain the token. The access token is going to be returned as part of the HTTP response in an HTML fragment. The MSAL library is going to handle the hidden sign-in request upon expiration. So this is going to be transparent to the user. It's handled via a hidden iframe renewal method. It's not going to also use refresh tokens. So this can have implications on the browser configuration, such as trusted sites and zones when you're using Internet Explorer or Edge, and the requirement of enabling iframes. So again, one thing that's not shown here in this diagram is that JavaScript apps secured via the Microsoft Authentication Library or the ADAL library should first call their own backend with the token that we get back to validate that it's a valid token that's meant for this application, and not just replying with a stolen token from a man-in-the-middle attack. We should be doing that. In this case here, we're omitting that step just to show you the functionality and how this stuff works. All right, so let's take a look at a demo of this application. This application has already been created previously, but there is a lab associated with this module that will walk you through the registration of the application and creating the application if you wish to try this on your own. So this is our Angular application demo, which is going to be using client-side JavaScript-based technique to authenticate, log in, and talk to the Microsoft Graph. So if I come over and look at the code for this, if I look inside of the scripts folder, I'll find a file called config.json. And this is where I'm going to do all the configuration for the authentication library that we're going to use to authenticate with the Microsoft Graph. So if you take a look at the configuration file here, what you're going to see are two things. You'll see a place where we need to specify the ID for the application. This is our Azure AD application we're going to need to create. And then we're also going to need to specify the exact URL of where we should send the user back to after a successful authentication. So this is the redirect URI that we need to put inside of our Azure AD application to send them back to our locally hosted web app. So clearly when you push this into production, this would not be localhost. You'd want to put this as a real URL. So let's go over to the app registration portal and let's create a new application. So I'll first go in and click add an app and give it a application name. So I'll just call it Angular Demo. Use the same email address and I'll go ahead and click create. So what that'll do is that'll create the application and pass in a new application ID. Now there's nothing I need to do for any secrets, but I'm going to need to add a platform for this. So the platform I'm going to pick is the web platform. Now when that's created, I need to specify the implicit flow is checked because that's the type of the OAuth flow that I'm using. And the redirect URL has to match that URL that I showed you in the config.json file, which is the localhost :8080. Now, make sure you keep that trailing slash in there. The application's expecting that, so we need to make sure that we put that here as well. It's got to match exact. So now that I have all of that set up, I don't need to set anything about the permissions because our application is going to request permissions. It's going to request those using the V2 endpoint and the dynamic consent. So I can just go ahead and click save. And after I click save and the application's been created, I'm then going to go ahead and select the application ID, go back over to the code, and then I'm going to paste that into the client ID piece right there on line 7. So now our application has now been fully configured. So I'm going to go over to my console and I'm going to switch over to the root of my directory, or to the root of my application. So I'm going to go ahead and start this application. First I'm going to npm install. The npm install is going to go first install all the NuGet packages that I need, the npm packages that I need for this application to run. And then I'm going to type in npm start, which will start the local web server for my application. Now, everything's running, so I'm going to go open up a new browser window and go ahead to my HTTP localhost 8080. You see here I've got my Angular app is set up. It's not logged in yet, so what I'm going to do is click the connect button. That's going to take me over to Azure AD to go authenticate. So now I'm going to go ahead and put in my credentials and go log in. Because the first time I'm using the app, I haven't consented this app to use my permissions to talk to the Microsoft Graph. So what I'm going to do then is review the permissions, and then I'll click accept to accept the different permissions. But notice that the permissions it's asking is asking for signing in as me, viewing my profile, and sending mail as me. Those were scopes that I defined in the config. That will take me back to the application here. We can see here that I'm back in my application. The application can figure out who the current user is, so it knows that my name is MOD Administrator. It's getting that from the Microsoft Graph. It's also getting my email address, and so now I can click Send Mail, and what that will do is send an email address or an email from the current user, and you can see here that we sent an email to that user. So if I'm going to go, and here's the application from the MOD Administrator. What this application was showing us was showing how to go through and do the configuration and to use a client-side based application to call the Microsoft Graph. So the API is basically the exact same for the Microsoft Graph. In this case here, we just had to see how the authentication was a little bit different from the console application that we just used a moment ago. In this section, we're going to talk about building Microsoft Graph applications using Azure Functions. So what are we going to cover in this? We're going to first look at the application registration. We're going to look at how to grant user consent, as well as how to grant admin consent. We'll look at creating the Azure Function project, authenticating without a current user, how to debug Azure Functions locally, how to publish Azure Functions to Azure, and how to monitor Azure Functions inside of Azure. The first step is going to be the application registration. Now, we've already seen this a couple different times inside of our previous sections that we did. In the previous examples, users could consent to the requested permissions. The application runs without an interactive user and requests the admin consent without the user. So in this case here, we have two different options where we can actually work with delegated permissions or application permissions. So how is this going to work? We are first going to have to grant users consent. So the way that this will work is that first, the user is going to be prompted to sign in. When they go to sign in the application, they will then be redirected back into the consent framework. So they'll be prompted for consent for permissions that do not require administrator consent. So here you can see there on the functions demo picture on the right, you can see that the functions demo needs permissions to view your basic profile and sign in as you. The other process, though, is to granting administrative consent. So the web application project and interactive user sign-on is not strictly required. The user could simply just go to a specific endpoint to go authenticate. The web application is used here to confirm the token permissions that have propagated prior to continuing. Note that there's currently a bit of a lag of approximately 30 minutes between the time when an administrator consent is granted and the data replication first succeeds. So there's a bit of information on the Azure AD samples Active Directory .NET Daemon v2 repository on GitHub as an issue on in that repository explaining what's going on. The link to that is actually shown in the notes on the slide on this module. So what you'll first do is open up the web application and then say grant the permissions, and then it'll take you to the administrative consent. You can see that consent, it looks a little bit different. And what it's going to also require is that you are the global tenant administrator, or at least are in that role to be able to grant this application permissions. Once the application has been granted these permissions, you're then going to confirm that the app has the required permissions by clicking the button, and you'll see that the application can now go fetch data for a specific application or from a specific tenant without requiring a user to log in, because the application is now running in a headless mode because it has admin consent. Visual Studio 2017 is going to introduce some new tooling for Azure Functions, providing a project template to quickly create functions, debug locally, and publish to an Azure subscription. You're going to choose from a trigger, such as a timer trigger, to generate the code. And it's then going to add the .NET NuGet packages as shown in other sections throughout this module. So how is this application going to work? Well, it's first going to go fetch the token, and then once it gets the access token, it'll then say go get all the users. from the Microsoft Graph and return all those users back to the actual application. Now let's look at how this application works. So from an authentication perspective. So there are applications that are referred to as daemon or server-to-server applications or headless applications. These are examples of applications that run on a scheduled basis and don't have an interactive user. So an admin is going to need to grant consent to this application. A general user can't do this. So we have some examples of how to go get this consent. What you're doing is you're going to be going to the login.microsoftonline.common or endpoint, and you're going to bypass the token endpoint and go straight to what's called the admin consent endpoint. You're going to pass in the client ID and then some additional information to go authenticate. That is then going to go through the administrative consent process where an admin user or someone who is a global tenant administrator in your Azure AD tenant, they are then going to have to go authenticate, log in, and then grant the application access. Once that's done, the application can then just go straight to the token endpoint to get a token that it needs, and then use that token to call back to the graph.microsoft.com. This flow, or this OAuth2 flow, is referred to as the client credentials grant because the client is going to be passing in its own credentials. The user will not be logging in for the application. When the application needs to run, it just fetches its own credentials on the fly. Now, functions, Azure Functions can be debugged locally. Output is going to be directed to a console window where they can log any messages that are visible, such as our message that is successfully synchronized a bunch of users here. Now, publishing the Azure function to Azure is relatively simple because a wizard is now provided in Visual Studio 2017. Once it's been published to Azure, you can manage it via the portal or using a CLI just like any other resource in Microsoft Azure. Now, this function that we're going to create, or that has been created in this sample, runs on a scheduled basis. So what you can do is you can then go look at the log messages in the sample to see how this works. And what this is doing is it's just synchronizing data between a specific tenant and locally inside the web application to be able to see that data. So let's take a look at that application that's built as an Azure function that leverages the Microsoft Graph. Now, keep in mind, just like the other samples that we have in this module, this example also is already built for us. So we're just going to go see this guy run and see it in action. If you'd like to build this yourself, definitely take a look at the lab that's associated with this module. So in this demo, we are going to show how to use Azure Functions and talk to the Microsoft Graph. And it's also going to use a headless application, which is also referred to as a daemon or a service. And that's going to run without any user involvement. Now, I've already gone through and set this up ahead of time, so as well as create the Azure AD application. So I'm going to just kind of click through and show you some of the important properties for it to kind of explore what the application's like. Again, if you want to do this for yourself, the hands-on lab exercise associated with this demo will walk you through all of the steps. So let's first start at the app registration portal, and let's take a look at the app that we've created here. I have one called Daemon Registration. See, we have our application ID, and then I also had to create a new password for our application. So I create that password. That's how my application is going to log in to Azure AD to obtain an access token. Now that token is, when it shows you that password, it's only going to show it to you that one time that you see on the screen there. So make sure that you copy that down somewhere for use, because you will never be able to get back to it again. You'll end up having to create another one in the future. You can create as many as you want, but that's only going to be available to you that one time. I also need to add a platform to it. I've selected the web platform. And I also need to specify some information about this too. I specified the redirect URLs. I'm going to use the one here for when the user logs in. That's just the naked URL that just goes without a extension on the end of it. It's just the port. And then I'm also going to need to show a way for them to redirect when they do an admin consent. We're going to do two types of consents. One is the delegated consent and one is an admin consent. So we have two different endpoints we want to send them to based on the direction that they end up going. I'm also going to need to add a permission. Now this application is using an application permission, so there's not going to be any interactive user logged in to use the application. because it's going to run headless. So the application permission that we've used is the user.read.all, which is requiring admin consent. So you can see if I open this up, we specified this one. You can notice that it shows that users can't even consent to this. Only admins can consent to it. So even though we are going to run this as a headless application, we are going to have a web application that we're going to use to verify that the application has granted, the user and the global tenant administrator have both granted consent to the application, either in the admin consent prompt, which is going to happen by the global tenant admin, or the user is going to grant consent. And we need to have a separate web application, as I said, to do that, to be able to make sure that this application has permissions to talk to the graph on behalf of this user or on behalf of all the users within this tenant. As a checkpoint, I am at 1459 remaining. Once we've actually granted our application access to these different permissions, we are then going to be able to use our Azure function, because then it can use the tokens and the ID and the passwords and stuff to go get the go get a token that can authenticate and talk to graph. But keeping in mind that in order to do that, we first had to go grant those permissions. That's what that web application is doing. All right, so let's go to the application. Let's see what we did. So inside the web config for my application, I pasted in the client ID and secret into our application, as well as the redirect URL in there as well, so that you make sure that you could actually get into this. You can actually see this application run. Let me state this part again. So the next step is, let's jump over to Visual Studio and let's take a look at the application itself. So what I'm first going to do is I'm going to open up the web config file, and you'll see here that what I've done is I've pasted in the Azure AD application ID and the secret into the web config, so that our application will be able to authenticate and get a token for this specific application. This is a note: don't try to use these credentials; they are long gone by the time you see this this video. Then, if I jump over to the home controller for my application, you see there's not much to it. I've got an index page and an error page. All it's going to do is just really to show a click here to get started kind of stuff. But if I look at the account controller, in the account controller, this is where that we're going to do sign in, sign out, and interactively have a user sign in to the application. Once the user has signed in, they will be able to click a button to grant permissions for admin consent to this application. So what we're going to do is we have one button called Request Permissions in the view, and when they click this, we're going to redirect them to an admin consent URL, and then we're going to inject the current user, the client ID, and the URL and code, the URI that they need to be redirected to once they actually log in and grant the permissions. This is the URL that you saw a minute ago from the Azure AD application that they're going to be redirected to. Now, when Azure AD grants the consents, it's going to return back to this HTTP controller that you see here on line 40. And what we're going to do is we're going to check to see if it was admin consent, and if it was, then we're going to redirect them to the user page or the user controller. So if we take a look at the user controller, what this is going to do is it's going to allow them to get all the users for a tenant, as you see here on line 34. So if I look at the definition for this, so in this function, get users for tenant, what this is going to do is it's going to try and get all the users for the current tenant, and it's either going to return back a collection of all of those users, or it's going to return back an empty collection. Now, if I jump over to the get method, this is going to be our headless part of the application. So here what this is doing is making an HTTP GET request. It's going to use an MSAL confidential client application. This is different from the two previous demos that we've done where we used a public client. The difference is that a public client doesn't have a secret, but a confidential client does have a secret. It uses its own authentication, meaning that it does not need a user to go log in on its behalf to go get the token. Instead, the application can go log in all by itself. So as you can see here, what it does is we're going to pass in the client credential. We're going to pass in the ID, the token, and all that. And once we get the token back, we can then take that access token and we can attach that token to the access header. As you see here, on line 46, we're then going to go wait for the response. If the request comes back with forbidden, effectively what that is there's a bit of an issue, at least at the time of recording, inside of Azure AD, where once we do an admin consent, it can take up to 15, 20, 25 minutes or so for that permission to take effect. And so even though we go through the consent, we may get a forbidden coming back, even though everything worked, and we really just have to wait for it to kind of get through this. That's what this big comment here is showing. So it's also the reason why I did this ahead of time, because I didn't want to have to wait for the 20 minutes when I was demoing this to you. So then once everything is successful here, as you see on line 67, it's going to read the values back, and it's going to store all the value back, deserialize the object coming back, and it's going to store all the users into this tenant array and store that locally so that we can use that later. So let's start with our web application, and let's make sure that our permissions are propagated. So I'm going to go to my user sync web application and fire this guy up. So here's our user sync application. I'm going to go ahead and click Get Started. And I'm first going to go ahead and click Sign In. So here, I'm going to go ahead and authenticate as my user. So here, when I go to sign in as my user, the first thing that permission needs is the user.read permission, which is view the basic profile and sign as you. The user can actually grant the consent to do that. So one of the things that's different though about this application is, if you recall, it's going to also need administrator consent. So you can see here that we've successfully logged in, and it's got the list of users here for this specific tenant, but see, no users are showing up yet. And that's because we haven't granted it permissions via the application or the administrative consent. So what I'm going to do here is I'll click the sync users now. What that does, it's going to check to see that I don't have the permission to go authenticate with the application. To start syncing users, the administrator is going to first need to go grant consent. So I'm going to click Grant Permissions, and this time I'm going to go sign in as my Global Tenant Administrator, which is the same administrator account. Notice the Global Tenant Admin is requesting different permissions, so like read all users' profiles and sign in and read users' profiles. But notice at the bottom that there's a little bit extra information about for granting a specific application permissions belong to all the users. That's the lot more information is being consented to here. So once I've done that, I'll be taken back to our application. And when I click on sync users this time, after 20 minutes or so, I should start to see a list of all of my users that have now been synchronized and pulled from my Azure AD, and then have pulled them back using the Microsoft Graph to display that information here inside of the browser here and show me a list of all those users that have been pulled in. Again, I did the magic of video editing. I was able to cut out 20 minutes that we had to actually wait for that permission to take effect. So as you saw in the code, we had a forbidden check that was probably going to happen. That happened for 20 minutes or so. We let that pass, and once that passed and it was finally successful, my users came back, and I just edited out all those times I was trying to see the users coming back and seeing the forbidden error coming back. So the next thing I have is I want to have an Azure function that can run headless without the user being involved. So I'm going to switch over in Visual Studio to the project here for Azure Sync function. You see I've already coded this guy up. Let's open up and take a look at the user sync.cs file. This guy's using the same kind of code that we just used a minute ago. So we're using a thing called a concurrent dictionary, which is storing a list of users by tenant. If I scroll down a little bit here, it's going to run once every 30 seconds. That's the syntax for doing every 30 seconds. Every 30 seconds, what it will do is it will execute this logic you see here starting on line 32, which is going to first go get a reference to our confidential client, which is going to get use the secret to go authenticate with the application ID. It's also going to leverage a local token cache as well. Now, once it gets the result to get the access token, we are then going to form up a new HTTP client, new HTTP request, and we're going to add in the access token to the authorization header value. and then we're going to make the request. So if I scroll up a little bit here, you can see the actual query that I'm running here against Microsoft Graph, and you can see I'm just getting a list of all the users. Now, the rest of the code that you see is basically the same as what we saw before. I'm just going to make the request. If forbidden's happening, I just log that. Otherwise, if it's successful, I log that as well. And then I'm going to get all those users coming back and deserialize those. And I'm also just going to log that information to the local console. So if I want to run this locally, if I go to local settings.json, you can see I've got using the Azure Web Job, the local storage. Now this is not the local emulator. This has to be a real one. So here I'm using the local one. You see I've just got those two things set up. I put the connection there for the storage account that I created in Azure. I've got the client ID and secret that I'm used for my Azure AD application. There's my Office 365 tenant that has all of my users in it. And here I've got my authority format and the reply URI, which is what's used by MSAL for authentication. And once the user's been registered, where do I redirect them to? So here, let's go ahead and run a debug instance of our Azure Sync function. This is going to run, again, this will run the function locally. So when the prompt pops up, it's going to ask about the Azure CLI tools. I'm going to go ahead and click yes. So I'm going to go ahead and let it go ahead and install those. And wait for that to finish. And once that finishes, I will see my console will load for the local emulator for the Azure Functions. So what happens now is that the Azure function is now logging in. It's executing the request. And I'm getting the output from the Azure function locally. Here I'm getting a little bit of a firewall request to unblock the Azure Function emulator. So I'll go ahead and say I accept that. So now I've got a debugger sitting here listening on a specific port, and then every 30 seconds it should fire that timer off. And what you'll see here is that the function is starting. We can see that the timer actually executed, and you can see it executed our function, and it successfully got 32 users. We actually pulled those across and everything worked just fine. So I could use this to check for any changes from a Microsoft Graph query and synchronizing that with a local application for a local store. So that's running the application locally. So let's see this guy running inside of Azure. So I'm going to right click the function and click publish. So here, when I click publish, I'm going to create a new Azure function. So I create a new Azure function application. I'm going to give it a name for whatever I want. Pick my Azure subscription, pick a resource group where I want this to go, and then the app service plan where I want this to be deployed to. Maybe if I don't have one, then I can go ahead and create one. And you can see here that I can specify where this is going to live if I wanted to in a different region, and then what the size of the VM would be for where my different VM would be selected, or I could even pick consumption. I'll just use it as the S1. Once I've done that, my application is now set as always on because I'm using a classic app service plan instead of the consumption plan. So I'll go ahead and click create. So once I've gone through and created it, it's going to ask me about any services. So I don't need to add any other services like a SQL database or anything like that. So I'll go ahead and click create. What this is doing now is it's creating the Azure function. We can see we've gone through step 1, step 2 in the bottom left of this dialog. And we just give it another minute or so, and there we go. Steps 3 and 4 went pretty quick. So here we got a summary. Everything's been created for our Azure function. So then I'm going to click publish, and what that'll do is deploy my Azure function up to the function that we just created. It'll also go through and deploy all of the settings to it as well. So how often it should run and all that stuff. Now, the one thing it is not going to have is the settings for the web app. So what I'm going to need to do is go back to the portal, to the Azure portal, and let's take a look at this Azure function we just created. So there's our Azure function we just created. So what we need to do now is I need to go set the settings for the application. So the way I'm going to do that is I'm going to come over here to the overview page for my Azure function. So what I'm going to do is I'm going to click the application settings at the bottom. And under application settings, if I scroll down to the bottom, I can see application settings here. This is the same stuff that I would have inside of a web config or my other configuration settings. So what we're missing from the application are things like the details about the application. So we need one called client ID with that GUID value. So I'm going to go ahead, come back to the browser, and I'm going to create a new setting here called client ID. I'm going to get the value, which is the GUID of our Azure AD application. I'll set that. Let's go to create a new one. And just for the sake of video editing or the sake of time, I've gone through and created and copied all those things in from that config file to save a little bit of time here. So all those settings have now been set. So I'm going to click Save to apply all of those settings to the application. And since I've updated the settings, I'm going to go back to the Overview tab. And if I come over here to go to the Monitor tab, so here on the Monitor tab, if I then select one of the entries here for the invocation log, it'll show the logs over on the right-hand side, and you can see here when the function was actually executed, and I can see that it successfully executed and synchronized 32 users. So we can see that the Azure function is now running on its own every 30 minutes, and it's actually showing us all of the output for successfully authenticating to use the token and the Azure AD thing, the Azure AD application that we had consented using the admin consent. And it's running headless now to grab a token and then call the graph to synchronize these different users. In this final section in this module, we're going to talk about building Microsoft Graph applications using a mobile application using Xamarin in the Microsoft Graph. Specifically, we're going to look again at the application registration, the NuGet packages, the application experience, and then a brief overview of the sample. Just like the other applications that we've looked at within this module, you're going to have to go through an application registration process, which is either going to be through the Azure portal or it's going to be using the application registration portal. In this case, just like the other ones, we're also going to be using the application registration portal. One difference, though, from the other ones, I guess it's similar to the console one, is that we are also going to be using a native application and not a web application in this example, because it is a mobile application. What you're first going to do when you go to work with the mobile application is you're going to need to add in a bunch of libraries to be able to work with this application. So you're going to want to install the Microsoft.identity.client project or NuGet package. And again, this is going to be in pre-release mode. Now, there are a bunch of different projects that are going to be associated here. So you're going to need to make sure that you install this to all of the different projects. As you'll see when we look at the demo, we have a Xamarin app. We have a Xamarin app for Android, a Xamarin app for iOS, a Xamarin app for a universal Windows package, and then also just the standard Xamarin app, like the root one. You're going to need to make sure that that's been added to all of them. The base one, the Xamarin app project, is also going to need the Newtonsoft JSON library as well. Again, keep in mind that the Microsoft.identity.client package is a pre-release package, so when you go to look for this, you want to make sure you check that little box you see there on the screen at the top that says include pre-release packages so that you can find the Microsoft.identity.client package that's currently in preview mode. So here's the application experience here. So what we're going to do when we go to launch this, the user is first going to be prompted to sign in. They're going to then be prompted for consent, just like we've seen in the other ones. And then their data will be securely returned using the Microsoft Graph API using the access token that the application obtained. So let's look at how this application works. It works just like the other ones in the sense that it's first going to go request the token from Azure AD. If the user's not signed in, they're going to be prompted to sign in to do that first. They'll then get that access token, and then that access token will be used by the application to call the Microsoft Graph to get the current user's profile, which will then be returned and shown within the application. So next up, let's talk a little bit here about the mobile applications and native applications and the authorization grant in V2 Flow. This works a lot like we saw previously in the console application and, in the console application for the authorization grant flow. What this does first is the user is going to then go to the authorized endpoint for Azure AD. That's going to require the user to both sign in and to get the token back and get the authorization code back. That authorization code is then going to be used to call the token endpoint to obtain an access token and a refresh token and return that back to the application. That access token is then used to call the graph endpoint. And keeping in mind that access token is only good for a certain amount of time, so eventually it is going to expire. But when it expires, we can use the refresh token that we got back originally when we got the access token to request a new access token and not require the user to sign in again. Again, all of that is handled by the Microsoft Authentication Library for us. So let's now take a look at this demo for working with we're going to look at the Xamarin implementation of using the Microsoft Authentication Library. All right, in this demo, we're going to build a Xamarin application. So I'm going to start by first going over to the app registration directory or app registration portal. And I'm going to give my application a name. So I'll give it a name of Xamarin app. And then I'm going to go ahead and click create. On the next page that we get, I'm going to give my app's got a name. It's got listed out. Now the only thing I'm going to need from this is the application ID. I don't need to do anything else. I don't need to do any application secrets except for the fact that I will need to add a platform. So I'm going to go ahead and click add a platform, and I'm going to pick native application. And then what that's going to do is generate a custom redirect URI. So my Xamarin application that we're going to demo is not an Android or an iOS application. If it was going to be an Android or an iOS application, there are additional instructions that I would need to follow for creating a native application using MSAL and Azure AD. So if you are building one of those kind of applications, you're going to definitely want to go take a look at the instructions for that. So I'm going to go ahead and copy my application ID and then save all changes so that it creates my application and saves it with the native application. So I'm now going to switch over to Visual Studio. Now, there are two classes that I'm going to deal with, or two projects. And one is the app.xaml and mainpage.xaml. And they have a code behind file associated with each one of those. Those are in a project type called a portable class library, or a PCL. It's a Microsoft strategy for sharing code between platforms. So it's going to be compiled down to a binary format. It's going to make things a lot easier and make code sharing a lot easier. From the Xamarin app, what it's going to do is I'm going to reference the Microsoft Graph and the Xamarin project. And you can see here I've got Graph, Graph Core, and the Microsoft Identity.client project. Those are coming from the NuGet package. And you can see in the UWP project, the Universal Web project, or Windows project, it needs to reference the same project types. So in this case, we're not actually going to use the Graph SDK and the Universal Windows app. Instead, we're going to make a raw request. So we're not going to, I'm not going to work with that. We're just going to use with just the standard raw request here. The nice thing is that all the code that we're going to write is going to be shared across the entire project. So let's go back to our PCL project. If I take a look at the code behind for app.xaml, if you can take a look at it, you see that I've got a public application that's created here and then defined the client ID. This public client application doesn't have a secret. If you recall, from the confidential client was the other option from previous demos. So what I'm going to do here is I'm going to paste in the ID for my Azure AD application that we created just a moment ago. The scope that it's going to request is user.read. So all of these are publicly available across all of the Microsoft project types, or different project types we have inside of a Xamarin project. So if we scroll down a little bit farther, you can see that when the app constructor runs, what we're going to do is going to create the public client application, and then we're going to create an instance of main page. If you first take a look at the mainpage.xaml file, then you can see that we've got the XAML that is defining the UI for it. So we have a couple labels, a box view, and a stack layout. What this is going to allow us to do is to click and populate the current user's display name, their given name, their surname, and their ID and the user principal name as well. And there's also a button here to sign in and sign out. You can see there on line 33. So let's look at the code behind file associated with this. So here what I'm doing is if I look at the onAppearing method, this is going to happen whenever our application page is shown. What we're first going to try and do is see if we already have a user in the cache already. So what I'm first going to do is I'm taking my PCA, my public my application we created in the app.xaml file. I'm going to try and acquire a token silently. So I'm going to go through and get my authentication result back. And if I do, then I'm going to call the refresh user data, passing in the access token to get the current user, the current information. If they are already logged in, which I would find that from my local cache, then I'm not going to pop up a login. But if a user is not logged in, then I need to catch the exception. And so here I catch the exception and I just switch over to an interactive mode where I show a button to where they can sign in. So I just take that text of the button and just change it to sign in. So when they click the button, that's going to fire the on sign in, sign out button. If the button is currently set to sign in, then I'm going to use the acquire token async, passing in the scopes and the app's UI parent. And that's going to call our own method called refresh user data, which we saw a minute ago, or we're going to look at that in just a minute, but you saw we called that just a minute ago as well, passing in the access token to get the user. Once we actually, if the user ends up signing out, then what we're going to do is we're just going to remove all the users out of our local cache. So we'll get rid of all the token, and then we'll change the button text to sign in. So if you look at our method get refresh user data, what this is going to do is it's going to see using the similar kind of code that we've used already so far. So it's going to create a new HTTP request. That's just a standard HTTP get, and it's going to go to the graph to go get the information about me, my profile. We're going to pass in the authentication header with a bearer token to authenticate the user and get that data back. Then we're going to make the request, get the response back, and then we're going to send the request asynchronously. Assuming we get a successful response, then we're then going to parse the result and display the properties and these different labels. The idea of this demo is really to show how to use MSAL to access the graph using a Xamarin application. So there's not, just to show you that we can use any kind of technology here to be able to take advantage of the MSAL and to authenticate and to talk to the Microsoft Graph. So let's go through and save our changes because we edited our changes for the client ID. It's going to choose different options I can choose from here. So you can see here in this case, I want to run the UWP project, which is going to be my Universal Windows application. So now if I go over to the start button, I can choose different options. So I choose local machine, simulator, remote machine, different options there once I've chose which I want to use. So here I'm going to choose the simulator. So what the simulator is going to do is just give us a nice little wrap box around the application shell. So now I'm going to hit F5 to go ahead and build the application. And it's going to take a moment for this thing to spin up. So through the power of video editing, I'm going to cut out the time here. Once you can see the console, it's going to open up a little shell wrapper here, show it looking like it's in Windows 10. So we can see the application start to launch. There's a button at the bottom there where I can click sign in. So if I click sign in, so it's going to connect to the service to go sign in to Azure AD. So I'll plug in my authentication details and click sign in to go ahead and sign in. It's prompting me for the delegated permissions. So here I need to accept it just like we have in previous demos. So I'll click accept. And here you can see it's just displaying the properties of the current user. So this demo showed how to make a graph call, show the separation between PCL and a UWP application. I showed you I didn't have to make any changes to the UWP project. All of it was in the PCL project to do the authentication.